Okay, Douglas, the floor is now yours. Let's just test your microphone first. If you could turn on your microphone so that we could hear you do your presentation. So if you could do that first, please.
Okay.
Excellent.
All right. So do you have my image or my my presentation image on the screen?
I have both you and your Airfoam background, as well as the perfect wall presentation in front of me.
Okay, that's grand. Okay.
You're ready to go.
I think we are. That's grand. Thanks very much, Susan. Hello, everybody. It's Douglas Benyon here from the technical department at Airfoam Industries. My work focuses around keeping our products current with the codes and also with the latest thinking in building science. So this presentation has a little bit different focus than some of the others. Although, Jason, you've got me ready to go out and tear my deck apart and put new railing on it. So thanks a lot. That's going to cost me a bunch of money. Anyway, so I'd like to talk to you a little bit about some options in that we have in meeting the new BC Energy step code. And I call this presentation In Search of the Perfect Wall. Now, is there a perfect wall? Well, as a matter of fact, some building scientists are saying that there is an assembly that they call the perfect wall. And what I'd like to do is I'd like to share that assembly with you right now, and how that could potentially not only bring you into compliance with the new BC Energy Step Code, but improve your bottom line and profitability. So most of you have seen this moniker from the province of British Columbia. It basically is a sort of a logo that explains the 5 step code levels from step 1 through step 5, or net zero energy ready. Many jurisdictions in BC have already adopted this to some degree, whether it's just step 1 or whether it's all the way up to step 5 with options, you know, to drop back to step 3, whatever it is. But the point is that hang on a second here, why am I not getting my, yeah, here we go. Okay. By 2022, we will basically be at a step 3 minimum, January of 2022. So the question becomes, how are we going to do that? All right. Now, there's a lot of ideas floating around out there. BC Housing, Natural Resources Canada, various building envelope concerns have all got ideas on how to do that. Many of them look like this. Okay. Let me go back here a little bit. Thank you. Okay, this is a deep stud cavity where you go from a 2x6 to maybe even a 2x8 or 2x10 or heck up to a 2x12 frame size, framed wall size, maybe even using engineered joists as studs by tipping them on their ends. Wow. And then a service cavity wall on the outside. These are the suggestions that are coming through from the province. Okay, what about, come on, let's go, come on. Here we go. Here's another one, double stud wall, two 2x4 walls, a 2x4 wall and a 2x6 wall with not 1, not 2, but 3 layers of insulation in between. This is what they're calling a high performance wall. I suggest that the problem is I'm not sure that our customers can afford this. These are, yeah, admittedly very high performance walls, but can we afford them? All right, the Natural Resources Canada LEAP program estimates that these walls are a 32, somewhere between a 32 and a 45% premium over the cost of what we're doing now with 2x6 walls. That is quite the gut punch for builders to absorb. There's got to be a better way. All right. I've got to get this figured out here. Okay. What about some older ideas? You know, structural insulated panels, insulating concrete forms. Well, I have hung acres, literally acres of structural insulated panels. And I know quite a lot about them. I will tell you that there is a lot of lumber in these things, and there's plenty of pathways for energy to transmit across this wall. that is the problem that our current framing methods present, is the energy loss through the studs, and we probably end up with an insulation layer on the outside of this premium panelized wall system anyway. So I'm not sure that that's the answer. Okay, insulating concrete forms. Full disclosure, my company makes insulating concrete forms. I'm a big fan of insulating concrete forms. But even I know that not everybody wants to build above the foundation level with insulating concrete forms. As much as it may make sense in a fire resistant sense, or because of lumber prices. I mean, there's a lot of reasons to build with ICFs, but not everybody wants to do that above the foundation level. So what if we use the ICFs for the foundation and hybridize the building with a different assembly, with a framed wall assembly that will get you not only compliant with step code 5, but still in business and able to make a profit. All right. So let's start with what you're probably doing right now. You're probably building an R24 nominal, R24 performance level about 18.7. And we call this a moisture control based strategy, because what we're doing is we're trying to keep the water from penetrating the cladding, and then a secondary water barrier, and stop it from going into the building. We are also putting a poly vapor barrier on the inside to keep airborne moisture from driving through the wall and getting into the insulation, because wet insulation is no insulation. We don't want that. Okay. So here's that same wall cross section from a physics point of view. Okay, if the external temperature is 0 degrees, internal temperature 21 degrees, we've got a nice warm, high moisture area on the interior that, because of higher pressure, wants to drive through to the inside of the wall. The problem is that because the temperature is low outside and we have put a nice layer of fluffy insulation on the interior of the wall, we are protecting that sheathing layer from the warmth of the interior of the building, and we end up with a cold sheathing layer. So if the external temperature is 0, internal temperature 21, what's the temperature of our sheathing? Well, the charts tell us it's about 5 degrees. Perfect environment to create condensation. Bad deal. We do not want condensed water inside the wall cavity. Mold, rot, insects, wet insulation that doesn't perform, compressed insulation, all of these problems because of water inside the wall. That's what we don't want. All right. So why don't we simplify life? Let's take all of the insulation and put it on the exterior of the building. Oh, really? Yes, we're going to eliminate the bats between studs. We're probably going to reduce the size of our framing, because we don't need a 2x6 cavity. We can go with a 2x4 cavity. We're going to eliminate the interior vapor barrier because we don't need it. All right. We're going to rely on a single water resistant barrier, air barrier, and vapor barrier, all three functions mandated by code and performed by a single layer that's placed between the sheathing and the insulation. Okay. All right. Now, 0 degrees outside, 21 degrees inside. What is the temperature of the sheathing? If you said about 21 degrees, you'd be right. Okay. So now we have a warm sheathing layer. What they call dew point is that area where the temperature is sufficient to create condensation, is probably somewhere out here in the first inch, or worst case 2 inches of insulation on the outside of the building. It will never get to the inside of this cavity. So what that means is that once we put an impermeable barrier, an impermeable membrane between these two layers, between the sheathing and the insulation, we know that the inside of the wall will always dry to the interior. The outside of the wall will always dry to the exterior. All right, 24/7, no high tech, no variable porosity membranes, it just works all day, every day. Now, here's a chart that represents a study that a bunch of us ICF guys did a couple of years ago. And basically, we were trying to prove that an ICF had a higher R value than all these other wood framed walls and steel framed walls that people were using. Okay, fine. 2x4, 2x6 walls, steel framed, 6-inch walls, all of it. So here is your code minimum for BC under the current code. Okay. And again, some jurisdictions have adopted the step code already, but the minimum code in BC is about 15.7 in a wall. This wood frame R24 wall is compliant because it performs at about 18.7, which is higher than 15.7. But if you drop back to R20 insulation, you don't make the grade. All right. But what have I shown you over here? I have shown you a 2x4 wall that performs at R20 and is enough in a energy calculation to hit step 5 in the lower mainland. We are doing it. We have had multiple cases where we've run calculations with this 4-inch exterior insulation, R20 assembly, and we're hitting step 5. All right. So here's the whole picture. We have basically an empty cavity, 3.5-inch cavity, no vapor barrier. Oh, what's this down here? Oh, that's wiring, because you can put wiring and plumbing and communications and whatever through this wall forever because you have an empty cavity that doesn't have anything in it. All right. Next comes your typical sheathing that you're used to using. All right, nailed through the studs. Over that, we put a high performance membrane, and I'm going to suggest a self-adhering membrane, not one that you staple on, because these joints seal so nicely with about a 3-inch overlap, and it's much easier to get your air barrier 100% effective with this self-adhering membrane than it is with a taped membrane. And the air barrier is critical to the whole step code compliance. Next is our rigid Coralite EPS insulation, the best value at the best price point per R value that you can find in the marketplace. I'm finding that our typical type 2 insulation is about 40% less cost than the extruded insulation you may have been using, the blue or pink version. Okay. So next comes a 3/4-inch furring strip that is screwed through into the building, performs 3 functions. Number 1, it holds the insulation on the wall. Number 2, it provides a nice 3/4-inch rain screen, and it gives you a great place to hang your cladding that one of the previous speakers so eloquently informed us about. And below, we've got an ICF foundation that, again, I'm going to say it's probably critical to the equation if you're going to get to step 5. So this is a cross section of that same assembly. All right, uninsulated 2x4 cavity, sheathing layer, membrane layer, EPS insulation layer, 3/4-inch furring strips, and then cladding on the outside. Very, very simple. So we've already covered why this is going to eliminate condensation and mold. Again, we are hitting step 5 with this assembly, and I'm going to suggest that there's a significant savings in materials because we've gone to 2x4 construction, because we're eliminating the interior vapor barrier, and one more key item is down here, where you see this sort of shaded pink area where you normally would have put some sort of insulation to insulate those box joist ends. All right, you probably are doing something like this, where you spray foam the end of the joist cavity next to the rim joist or box joist. But what we know is that this insulation down here has to be basically the same as what you've got in your wall. So if you're R24 up here, you've got to be R24 down here. Now, maybe you're using spray foam insulation. I don't know. Maybe that's too expensive and you're using something like this, a piece of rigid insulation with spray foam, with the backup of bad insulation. I'm not sure what you're doing, but the point I want to make is we don't need to do any of that. Okay. The exterior insulation that we've brought down the wall runs past the rim joist, past the green plate, and meets up with the ICF below. So now we have a contiguous layer of insulation on the outside of the wall that eliminates the need to insulate these box joist ends, which is a real pain. I know for a lot of you. Okay. So cost savings because of the elimination of the box joist insulation. A couple of other points: your insulators are now working outside of the building. In fact, your framers are probably putting this insulation on the building. They're not inside tripping over the electricians who are tripping over the plumbers who are tripping over the poly guys. You have fewer trades, fewer people on site, and you are building a far better product, probably at a lower cost, and you are step code compliant. All right. So what we would like to suggest is that the Quadlock R28 foundation and your Coralite insulated exterior insulation scheme become your go-to step code compliance assemblies. We believe that because of the cost savings and the time savings with the ICFs and with the material savings of the and the effectiveness of the exterior insulated system, that these are going to become your go-to compliance assemblies. We're doing it for customers now, and we'd like to do it for you. So with that, thank you all very much for joining us. We have a ton of information at www.airfoam.com, www.quadlock.com for the ICFs. Don't forget to join us on social media. We have a new learning center that we are producing podcasts, and by the end of April, you will be able to access this presentation and many more like it, either in webcast or in podcast form from our streaming services. So, how did I do, Susan? Are we good?
Thank you very much, Douglas. Wow. Okay. Let